short lesson. And I wonder if this lesson will open more questions than answers. Be prepared for that. And that's okay. I'm going to answer the questions eventually as we learn about quadratics. I'm going to show you some new things. And don't be surprised if things happen that you're like, okay, but what about this then? And I don't have all those answers for you just yet. I've got some things for you, but not everything. So no panicking yet about the whole picture. Learning goal. Relate the factors. The factors? What do you mean factors? Yeah, I know. What do you mean factors? I got to show you. Of a quadratic relation to the key features of its graph. Okay, until now, the quadratic relations we have worked with were of the form, okay, I'll write the fancy form. Get ready. Fancy form is y equals ax squared plus bx plus c. And the reason I say fancy form is the a's and the b's and the c's, when you're first learning this, can mess you up. Like, what is going on? A, B, C. Yes, sir. Oh, you want to go get yours? Yeah, that's all right. The A's, B's, and C's can mess you up. You're like, what do you mean A? What do you mean B? What do you mean C? Yeah, totally. You're totally in the right frame of mind if that's what you're wondering. So over here, I'll show you what I mean. Over here, I'll be like this. This is what I mean by A, B, C's. Maybe we'll do a parabola that's like 2x squared plus 4x minus 3. Maybe it'll look like that. And the A would be 2, the B would be 4, and the C would be negative 3. We got to get to the point where these A's, B's, and C's, we're going, oh, the A's, B's, and C's just represent numbers that might change in any particular question. Or maybe it's like this. Y equals 5x squared, or negative 5x squared, plus 9x plus 7. That's what we've seen so far. A quadratic with a degree 2 term, a degree 1 term, and a constant term. Now I'm using the fancy words, aren't I? Degree 2, degree 1. Now, some of them can be 0. I could have y equals 3x squared minus 9. I don't have to have an x term. That's still degree 2. Do you agree? It's got exponent 2. I could even have y equals 2x squared plus 5x. I could even have y equals negative 7x squared, just a degree 2 term. So after that's all done, you go, okay, we can have anything for the x, anything for the number, the constant, including 0, but a can't be 0. You got to have something in front of x squared. So over here, this usually says a can't equal 0. We don't always write it, but we usually put over there a can't equal 0 to remind ourselves to be a quadratic, you've got to have an x squared term. You don't have to have an x term. You don't have to have a constant term. And I'm going to try and use that word more and more, constant. Constant is just the number that doesn't have a variable in it. Yeah? So now I can reread my sentence and maybe understand it. Up until now, quadratic relations have looked like this. Y equals ax squared plus bx plus c. Some x squareds, some x's, some constant. Maybe that's a better way to read y equals ax squared plus bx plus c. Some. Every time you see a letter like that, you go sum of these. And y equals mx plus b too. Y equals mx plus b, what that really meant was y equals some number of x's plus some number. That's what really y equals mx plus b was trying to tell you. Even though we put m's and b's, they were like training wheels. The m is the slope, to really memorize it. Okay? When quadratics are given this form, it is called standard form. And what I mean by that is that's what you'll usually get. You'll usually get standard form. But I have 2 more forms to show you this month. And I'm going to introduce one today. One of the other forms that I'm going to show you.
So, is that form the same as that?
Yes, these are examples. So that's good. Good point you're making. Example. E.g., for example, here's a bunch of examples of what it will look like. This is the look of it. And here's what you'll see when you see it. You'll see all different A's, B's, and C's depending on the question. Okay? In this quadratic, when it's in this form, we can find, okay, let's test ourselves. If I give you this, what can you figure out about the parabola? It's not much. Let's not get carried away. We're only on day 3 here. What can you figure out just from looking at this form? The y-intercept. I think that's number 1 on the list. We're going to put it number 1. Because you can just look right at it. Negative 3, 7, negative 9. 0, 0, you know. Just like y equals mx plus b, the constant number is still the y-intercept. So that's good news. We can easily find the y-intercept. There's not much else. There's not much else. Oh yeah, actually, I'm going to put that down here. She's got a bonus one that we just talked about yesterday. It really wasn't supposed to be a big part of yesterday's lesson, but in the last example, we found out we can get the step pattern. One A, 3A, 5A, whatever that A value is, whatever that number is out front, we can pick off that step pattern. But that actually isn't one of the two things that I really expected you to be able to pick off at this point. There's one other thing. Right, the direction of opening. Mr. Todd, I'm sort of with you. I believe you that it should get the y-intercept, and I believe you that the direction of opening, that we can get it. But how do we get it? Here, in brackets, a little note about that. The y-intercept will be the c value. Do you see why the a, b's, and c's are there? So we can talk about them. We can say, oh, this is what I'm talking about. The c value is the y-intercept. So the direction of opening is a greater than 0. It opens upwards. A less than 0, downwards. You know that? Up, down, positive up, negative down. Positive up, negative down. We okay so far? Maybe you're like, yeah, I'm okay because you haven't really done anything so far today except continue to review all the words. And that's what I warned you about on day 1. I said a lot of new words, but also a lot of time to get used to the words. You have questions? On page 1 of 6, on mine, it's page 1 of 6. Maybe some spicy examples coming at the end. Yes, are we excited for some spicy examples? The ones that just push us a little bit. Do you need more time there? I put step pattern underneath because I'm like, we just kind of sort of know that. It was barely, we just saw it a little bit. But I like putting it there. I like that it's there. I like that we got it too. Who got that one? Huh? Destiny got that one? Is it good? Oh, comma, dot, dot, dot. That's not me being nitpicky. That's just saying this thing goes on. The parabola goes on forever. Yeah, okay. All right. What's next? Okay. If you're sleepy, you're already left for Easter. Yeah, your brain's gone. Might want to bring it back for a minute. This is the new stuff today. A quadratic formula can also be expressed in a way like this. Y equals a x minus r x minus s. What? I know, it's brand new. Relax. Build that into yourself when you're learning math and science. When something's brand new and the first time it's written down, you're like, I don't know what's going on. Just relax. Deep breath. Like, okay, this is what we're learning about. Apparently, it can also be written like this. I'll need someone really clever to explain why it's the same. But here's some examples. We'll see a lot of these. We will like this form. We are going to love this version of quadratics. So maybe it's going to look like this. Y equals 2 bracket x minus 5 x plus 2. Or maybe it's going to be like y equals negative 3 x plus 1 x plus 4. Maybe the quadratic will look like that instead. Brand new. Yeah? A little scary. This form is called factored form. And this is what I was talking about, is that maybe this lesson is going to give you more questions than answers. You'll be like, yeah, but how is that one the same as the other quadratics? How do we get it? Oh, how are we going to get from this form to the other form? Oh, yeah. Got a whole month of stuff to open. So this is like we've walked into the Cave of Wonders. Oh, did you see the movie The Hobbit? Yeah? Yeah, okay, there's a scene in The Hobbit where he finally sneaks down into Smaug's lair and opens it up, opens the door and peeks in, and just a giant mound of all kinds of treasure that you'd ever want to see. That's what just happened here. You just opened it and went, what is all this? Yeah? Don't freak out. Go, okay, this is factored form. At the end, little note to myself, little star down here to remind myself. At the end, I'm going to ask someone to try to explain how this could possibly be a quadratic. For now, you just have faith in me for a little while. Just a couple minutes, you have faith that this is a quadratic. They can look like this. And at the end, we'll see if there's somebody who can see why that's true. Okay, now my sales pitch for this form. Me trying to convince you that you're going to like this form. Here's what we can get from this form. You haven't seen it before, but I'm telling you, this is what we can get from this form. We can get the direction of opening. We'll be able to get that. Yes. We'll be able to get the step pattern. Yes, no problem. We'll be able to do that in this form for sure. We'll be able to get the zeros, which are the x-intercepts. We'll be able to get those, and friends, we'll be able to get them easily. It'll be the easiest thing you've seen in a long time to be able to get the x-intercepts when we're given in factored form. We'll be able to get the axis of symmetry. We'll be able to get the vertex, which means that we got the vertex, we can get the optimal value. Sales pitch over. It's okay if you're like, I don't know how you're going to do any of those things. No, that's just me selling you a brand new product, going, wouldn't you like an equation where you could get all this stuff? And when I say get all this stuff, I mean, it'll be easy. If it's in nice factored form, I can do, let's do it. Shall I? I'll do it right now. I'll go over here and I'll tell you from this one right here, I'll tell you everything I can that I know. And it could be, as I'm doing it, you're like, oh, I think I can maybe do that. Maybe. Huh? I'm jumping ahead here. Jumping way ahead here. Direction of opening. Down. Yeah, this one. I can tell. There's a negative up front. It opens downwards. Not too bad, right? I got to teach it to you, but not too bad. Step pattern. -3, -9, -15. I just take the 1, 3, 5 pattern and multiply it by the -3. That's still the A value out there. When we're done factoring, the A value will still be out there. It'll do all the same stuff it did before. Zeros. Watch this. X equals -1 or X equals -4. It's okay if you don't know how I'm doing that. But maybe you can peek at it and go, I got some feeling how you're doing that. That doesn't look that hard. Axis symmetry. Ooh, halfway between -1 and -4. X equals -2.5. Don't worry about how I'm doing it. Just notice I'm doing it fairly easily. Maybe you got some hint. Maybe you can look at it and go, oh, I maybe see what you're doing there. And optimal value, ooh, that is a little tougher. I'll have to go y equals -3, sub in the -2.5 into the x, and punch that in my calculator to get the answer. Okay? I didn't have to do any of that. Maybe I shouldn't have done any of that. Maybe it's because you're in AP class. I'm like, here, let me just show it to you real quick so you're not too mystified by what's going on here. Star. What was the star? What did I want to do? Oh, I want someone to look at this and tell me how it's a quadratic. To be a quadratic, it's got to have an x squared. And it's okay if right now you're like, Mr. Todd, that doesn't have an x squared. Where's the x squared in this?
You're supposed to multiply 3 with the values in the first bracket, then you're supposed to multiply the 2 values obtained in the other bracket.
Her algebra is strong, my friends. She says, I'll rephrase. If I distribute this out, and the distribution is going to be slightly different than we've seen before, but immediately I'm going to go x times x, which is x squared. That's enough for today. There's the degree 2. It's laying right there. I got a degree 1 here, but multiplied by another degree 1 there, it's going to be degree 2. Hi there. Welcome.
Do you think you have an extra practice test for tomorrow?
Not in this room, but it's on the website.
Yeah, I have it.
Yeah. So I'll finish teaching here before 11. Yeah. We could go, if you come back again at 11, we could walk to the other room and go get it if you wanted.
Okay,
You let me know.
I'll also be
Okay. Yeah, we'll get it then. All right. What was I saying? Oh, distribution. That's how we get from there to back to the other one. And I got to teach you that distribution. I got to teach you that. I believe it's Tuesday's lesson. Like, okay, let's figure out how to distribute these things. How do I get from that, the standard form, back to here? Oh, that's going to be a war. Okay, so we got lots of work to do. Any questions there, though? That page took a long time. What's that?
How do you find the y-intercept?
The y-intercept? Oh, yeah. He makes a great point. He busted me. I was doing a sales pitch going, this thing does all those things. He says it doesn't do the y-intercept? I'm like, not too easily. Could, though. I could make x equals 0 here, sub in x equals 0, and then multiply it out. So I didn't put it on my list because it's not super easy. It's not as easy as the other one. So there is a little bit of sales pitch for standard form. Standard form goes, I can do y-intercept really easily. Factor form's like, well, I can do it pretty easily. But look at all the stuff I can do. Yeah? So can you do it yet? No, I didn't do this stuff to like, you should know this. This isn't the you should know column. This is like, look how easy it's going to be once we get used to it. Oh, let's do one. Here we go. Actually doing it. The zeros. Okay, long sentence here with an easy finish. By just looking at the equation, can you tell me an x value I could sub in where this whole thing on the right side would come out to be 0? And I'll prove it if you can come up with the x value. What x value, when subbed into that factored form, this thing's all got to come out to be 0. I'll rephrase. 0's not going to do it. Let me rephrase to help. What number could I put right into that bracket right there? What x value, if I put it in there, would make that bracket 0? 4. And if that bracket's 0, and it gets multiplied by 2, that's still going to be 0. And then I'll have 0 and multiplied by, I don't even care what comes out of the other bracket. Okay? So the zeros. X equals 4 is the first one. Having seen that, can anyone tell me what the other one is?
2?
Negative 2 this time.
Oh, because it's not subtract.
Yeah, because it's not subtract, it's add. And actually, the way we'll write that, I'll write a little work over here. The work actually is, we need x plus, not x plus 4, x minus 4. We need that bracket to come out to 0. If this whole thing's going to come out to 0, I need x minus 4 equals 0, and then I can move the 4 over. That's the work involved in pulling this off. But maybe you're like, I don't need the work. Just look at it. Something minus 4 is 0, that's 4. And the other work is x plus 2 equals 0. So x equals negative 2. So let's try this one then. Just by inspection, can anyone look at this second one and go, I know what x value, there's only one this time, can make this 0? 3. She just looks at it and goes, x equals 3. And this is what I was talking about, this will be easy. Is it easy right this second? Maybe not. But when you just look at it, you go, okay, I just got to look at it and think about what x value makes that bracket equal to 0. And there's only one bracket this time. X equals 3. Okay, that's good. Now to address your problem, you said, how do I get the y-intercept? To get the y-intercept, let me write it over here, set x equals 0. So I over-dramatized it, actually. I said, oh, it's much easier in standard form. It's not bad here. You just sub in 0. So you go y equals 2 times 0 minus 4 times 0 plus 2. And I get negative 16 when I multiply those things together. 2 times negative 4 is negative 8, times 2 is 16. The zeros are sort of irrelevant in the calculation. So how about this one? Set x equals 0. Y equals negative 5 times 0 minus 3 squared. I'm going to show an extra step here. Negative 5 times 9, negative 45. So was it that bad? I acted in the last screen like, oh, we can't get y-intercept. Well, subbing in x equals 0 is one of the easiest subs ever. Maybe Turkey would be the only other easy sub I can think of. Turkey sub. Yeah. Best I can do on Thursday, sorry. Well, now we need somebody clever. Equation of the axis of symmetry. I think this was in the homework. You had to deal with this situation. One of the x-intercepts is 4. The other x-intercept is -2. Where's the axis of symmetry? Dun, dun, dun. He's doing something, folks. He's done something. I'm not. He's going to tell me all his work in a minute. He says it's -1. Can anyone tell me what he did on his calculator? He went dun 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 dun. He punched a bunch of stuff in to get the answer. What did he punch in? What did he do? Oh, it's not. Here, type it in again, because it's not right. I played along with you. Here, do it again. No. Oh, here. I'll just do one thing to help you. Yeah?
So 4 plus 2.
4 plus -2.
4 plus negative.
I'm giving it away now.
Yeah.
1, +1. There we go. What did he do? Oh, yeah. Okay, that's what he did when we got the wrong answer there. To get the right answer, you had to use the zeros. Yeah. Messed up. But that's all part of what we're learning here and why we're taking it slow. They went 4 plus -2 over 2. Where are they getting that from? What does that remind you of? It's midpoint. It's just the midpoint of x. We're just finding halfway between the two x values. Little picture. X-intercept at 4. X-intercept at -2. Where's the axis of symmetry? Halfway between. Now, you might be like, can I just count it? The answer is yes, but what if it's decimals or if it's big numbers? Yeah, that's when we use that. But it's right here. There's the axis of symmetry. Halfway between those two. So, this one's easier. There's only one x-intercept. 1, 2, 3. There's the parabola. It's 3 plus 3 divided by 2. Both intercepts were 3, if you want. I don't know. People don't like that. When there's only one x-intercept, it means it's the vertex. So the vertex is just x equals 3. Or the axis of symmetry is just x equals 3. Notice how I've gone to graphs there, though, friends. When confused, like in lines, graph it out, write down what you have, and then you can see. Well, now we need somebody crazy clever. I'll try and lead them to it. The vertex for the first one. I'll give you a hint. Here it comes. We know the x value of the vertex. We already got it. It's already on the page there. It's 1. Whatever this vertex is, it's got to be on the axis of symmetry. That's why that silly definition yesterday, or 2 days ago. What did I say? The vertex is where the axis of symmetry hits the curve. And most people looked at me and went, why are you saying it like that? It's the highest or lowest or point. I'm like, I know, but right here it's helpful to know. Once I have the equation of the axis of symmetry, that's the x value of the vertex. We did that in reverse. We went, here's the vertex, what's the axis of symmetry? Now I go going the other way. Axis of symmetry, what's the vertex? Okay, that's my hint. What am I going to do with that x value? Now that I've got it, to find the y value. If only I had an equation that turned x values into y values. Does anyone see anything that can be subbed into with the x value that specifically gets y values? Like it literally would say y equals when you have the x value. Any ideas? Oh, the equation. That's what the equation does. It says, you got an x value? I'll give you the y value. I've got the x value. So there's my work there. I go y equals 2 bracket 1 minus 4, 1 plus 2. Some extra work this time. 2 times -3 times 3, negative 18. I could do that in the other one, and I will. Can anyone tell me the vertex, though, without all that work? This one's easier. 3, 0. Okay? So maybe that is one little extra piece of stuff for your brain today. When there's only one factor, x minus 3 squared like that, that's the vertex, 3, 0. Yeah? So yeah, I could sub in the 3 in there. I could go y equals negative 5 times 3 minus 3 squared. Y equals negative 5 times 0 squared. Y equals 0. Friends, I'm not trying to pretend that's easy. Those are a little bit tricky to tie together all that stuff. So I got good news for you. On Tuesday, I have what's called a mid-chapter review, a work period on Tuesday just to go, stop, let me just go over it all again. And there's a nice mid-chapter review, and I'll have your practice quiz for you. You know, we can as slow as we're going, we're going to slow it down even more and make sure we got this down pat. I think there's more on yours, though, isn't it? Yours goes down to EFG from there. Yes? E, the optimal value. I hope that's easy now, if you've been keeping up with homework. The optimal value is that high or low y value. I get that right from the vertex. This one's y equals negative 18. And this one was y equals 0. Direction of opening. Yeah. A equals 2, up. A equals negative 5, down. Also big news. The A value survived. Whatever the A value was, whatever that leading coefficient was, we'll call it later, that number is the same number. It's out here. Yes? That will decide direction of opening. That's good news. Sketch the graph. I already did that, didn't I? But I'll do it again. So what have we learned about the first graph? All the stuff we have, we found out that it had zeros of 4 and negative 2. It had an axis symmetry at 1. Its y-intercept was negative 16. Its vertex was 1 comma negative 18. So the parabola looks something like that. I encourage you to get some graph paper. Or maybe it's just time to switch over. We're going to do a lot of graphing in the next month. Maybe it's time to just get one of those graph paper notebooks, one of those fancy 5-star ones from Staples. I use the Hilroy ones because I love them. Do you know the Hilroy ones I'm talking about? I use them for everything I do now. Yes? Graph paper. So if I'm doing algebra, and then suddenly the next question says graph, I just go ahead and graph. Yeah? Nice. Where was I? Graphing this one. Downwards, vertex 3, 0. Y-intercept was something ridiculous. Negative 45. Now, friends, we will do better than this soon. We will incorporate the step pattern to get more points. That's not what I was trying to accomplish today. Today I was just trying to go, hey, we're pretty close. With some x-intercepts and y-intercepts, we're pretty close to getting a pretty good graph of this thing. Questions? More time? Okay. Total new skill here on your last page. To find the equation of a quadratic relation in factored form, use the zeros to get the factors. I'll put a smiley face there. I don't think, after we practice it a couple times, you're going to find that particularly difficult. Yes? Keep the a value out front. Sub in a point to solve for a. You've actually done that last step before. You subbed in a point to solve for b when you were doing y equals mx plus b. And this will be very similar. This is a tough algebraic skill, though, friends. Get ready. The graph of quadratic relation has these zeros. Ooh, little smiley faces. Oh, they gave me the zeros. Happy? Happy. I'm so happy to see the zeros and pass through the 0.35. I'll get to that. Here's my steps. Notice I did it 1, 2, 3 like I did with lines. This is the 1, 2, 3 for quadratics. 1. Use the zeros to come up with the factors. Is there someone clever out there? Got to really think this through. If it's got a 0 of x equals 2, what will one of the factors be? X minus 2. You just hit a home run and you didn't even know it. Yeah? That's amazing thinking. To be able to take what we did in the previous page and flip it around and go, okay, if the zero's x equals 2, the factor must have been x minus 2. Good stuff. If you're not there, get caught up right away and go, what? How did she do that? Let's do this one. If the zero's negative 6, what's the other factor's x plus 6? That's a huge first step. Here's step 2, friends. Write the a value out front. Say, well, but I don't know what this a value is out there. I use little a's in grade 10. I really want to use a capital A because my little a's look like little 9s or 0s. I'm not really good at writing little a. Maybe you are. I give you full permission to switch to capital A's, though, if you're like me. I'll try and struggle along with the little a's. There, that's step 1 and 2. Let me put a little 2 into there. Put that a there. Yes? And now I'm going to do what we did in last chapter to find the y-intercept. We were finding b's. I'm going to sub in 3, 5. 5 goes here. 3 goes there and there. And as bad as it looks, the worst is over. The worst is over. Because what's 3 minus 2? 1. What's 3 plus 6? 9. What's 1 times 9? Last step to solving for a? Divide by 9. So your algebraic skills are now going to pay off. Therefore, y equals 5/9 x minus 2, x plus 6, and I am so happy I could dance in the street. That is some unbelievable algebraic power to be able to pull that trick off. It took knowledge of zeros, it took knowledge of factors, it took knowledge of subbing, all your y equals mx plus b skills, all in one crazy question. Whew. That is a beaut.
Why does it become 5 over 9?
To get a by itself, you got to divide both sides by 9. Yeah? Is it okay? Other questions about that? I didn't mean to rush it. I was trying to keep the flow of consciousness going, trying to keep the brain focused on the plan. But that is so tough, we'll do another one. You know the answer to the other one? You know what to do? Okay, we'll do it together. I won't totally hand it over to you. I know sometimes I hand it over to you and I'm like, you guys try it. We'll do each step. We'll give you time on each step in the next one to think it through what you're going to do, and then we'll share. And we'll go through it step by step together. Because that was pretty fast, on purpose. To go, here's the big plan. Now let's go back.
Is it just that? It's the same question.
Oh, it is. Somebody was not very creative. All right? Well, let's pretend we didn't know, okay? He's seen something clever, but we're going to walk through it. Determine equation for the parabola. Step 1. Y equals, can you get the two factors? You take a second right now and see if you can get the two factors from those zeros. Challenge yourself. Only peek at the previous question if you have to. More time? I'm not trying to rush you. Who wants a shot at this? Has got both factors?
Plus 2. And x minus 4.
Yeah, always the opposite sign, right? Because if I put -2 in there, that'll make that factor equal to 0. Do you remember what the next step I told you to do is? Put the a out there. Step 2 is write 8. I can't do it, friends. My little a's are terrible. I'm over it. I'm big A the rest of the way. Are we okay? I think I did it with B's too, didn't I? I cheated. Every time it was a little b, I'd write a big B because my B's look like 6s. Yeah? There's A. Same A. I'm not changing anything. It's A. Good. I need to know the A. How do I get the A?
7, -16.
Yeah, in future grades, we should start calling it sub and solve. Oh, I just sub. The grade 11 say it all the time. Oh, I can just sub and solve. They're so used to that. They do it so many times. You did it last chapter. Now you're doing it this chapter. Sub in something you know. Sub in. Oh no. Sub in what? What's the point? 0, -16, because it's a. That's where it crosses the y-axis. Ooh, little curveball there at the end. Yes. Now we can sub and solve. So I put -16 over here. And this looks bad, I know. But it's not, friends. I know it looks like a big, hairy, scary mess, but it's just not, because each individual calculation is not a big deal. What's 0 plus 2? 2. What's 0 minus 4? -4. And what's 2 times -4? -8. And I put it out front because I'm used to seeing the coefficient out front. But let's not pretend I did anything dramatic there. And then final step? Divide. Divide by -8. You've seen steps like that before. And now I've got the A value. Yay! Don't give yourself credit. If you're in the homework and you land one of these things, you're like, I'm pretty good at algebra. That's a spicy question, friends. That's enough spice. You ever seen them do those those wing challenges with a celebrity? Celebrity goes up and eats the first one. Like, yeah, I eat spicy wings all the time. By about level 6, they're like sweating a little bit, drinking a little bit of milk. You can see them. It's changed. That's what this is. It's like, yeah? You thought you were good at eating spicy wings? Here, give this a try. So if you knock it down, you can be proud of yourself. Look, Mom, look what I did here. How about a therefore statement there? Therefore, y equals 2, x plus 2, x minus 4. Oh, that's good. The second time through, that's good. So that was spice level 5. That was enough to make you a little drop of sweat in your brow. Okay? Reach for a little sip of milk. You didn't want to drink too much. You didn't want to seem like you were fazed by that. This is level 7. This is like you bite it and go, ouch. Determine the vertex.
I know the vertex.
He's peeking back at the previous question. Let's go from here, though. If I had this information, what would I do first to chase this vertex? Add them together, okay? And sometimes we write x with a little v there. X value of the vertex. That's what I'm chasing here. She says add them and divide by 2. You're actually doing midpoint. But you're like, I only need the x value. I only need the x midpoint here. So I get the x value of the vertex, and I almost wrote 2 over 2. I get the x value of the vertex, which is equal to 1. Okay, that's good. We've survived level 1. Took our first bite at the wing. We went, okay, I can do that much. Now, if you're going to chomp into this thing, how do I get the y value of the vertex now that I've got the x value? Just sub it in. Just sub it in. Yeah, getting y values from x values at some point, not yet, but at some point that's got to be easy. Like, oh, where's the y equals? You look around the page and go, somewhere y equals. Ah, sub in x equals 1, y equals 2, 1 plus 2, 1 minus 4. Looks like a big mess. It's just not a big mess. It's not really a big problem. 2 times 3 times negative 3, y equals negative 18. Therefore, vertex is 1, negative 18. And I know that was the same as the previous question. We didn't mix it up very well there. I'm going to do one thing to try and help. You don't have to do this, but I'm going to put a little v beside the y to say this was the y value of the vertex. Little things like that can help to keep you organized. I don't know if this is digestible homework or not. I suspect it's not. I suspect there's a little indigestion coming. But you got 4 big days to do it. What would I do? Option 1, go home tonight, knock this down, and have a nice Easter weekend. Option 2, Thursday, do 4 ACE. Friday, 5 ACE. Saturday, 7 AC. Sunday, 10. And 12 on Monday. First thing out of bed. You roll out of bed, don't reach for your phone, wipe the sleep out of your eyes, do one question, and then enjoy the rest of your day. This is called scheduling. It's a wonderful anti-anxiety method. To go, yeah, I'm going to do my homework. I'm going to schedule it. 9 a.m. Or what time will you guys get up? What time do you guys get up over here? And some laughs on their face like 11 a.m.? 9? 9 p.m. I'm going to get up. When you get up at 9 p.m., the first thing you do, you roll out, brush teeth, have a drink, whatever it is, and then you go, knock down one question of homework, and now I can enjoy the rest of my week, my day. I don't have to stress about it. See, scheduling helps with stress. I was like, bang, done. No, Miss Todd, that's not my plan. My plan is to spend all weekend worrying about it, letting it bounce around in my stomach, stressing about, I still got homework. And then Monday night about 9 o'clock, I'll try and dig it out and work it on there. Do you see how you ruined your whole weekend? I'm not talking about like an adult talking down to kids type of thing. I'm just saying, why do you want to live like that? By each morning, doing one question, you get your whole weekend free of anxiety. Clever stuff. That's what adults do that you don't, maybe. That's why we seem a little less stressed. We're on the case. Yeah? Well, maybe not all adults. Maybe some adults haven't. Maybe you know adults that haven't got this figured out yet. Yeah? Yeah. I'm going to do you one better, Miss Todd. With 25 minutes, I'm going to knock down Thursdays. I'm going to knock down Fridays. And I'm not going to take another look at this till Saturday. Good stuff.